Greetings students. Today we are going to see how to do the project scheduling using critical path method. That is, how to find the critical path of the given network and hence how to calculate the total duration to finish that project. Using critical path method, I am going to explain to you. Let us see this method by taking one problem as example. Take this problem. A project consists of a series of tasks, namely A, B, C, D up to I, with the following constraints. The constraints are given like A less than D, E, B, D less than F, C less than G, E less than H, F, G less than I. What does all these means? For that, the explanation is W less than XY means XY cannot start until W is completed. What does it mean? If you have less than inequality, then the activity task in the left is the predecessor of task in the right. Okay. So task in the right cannot start until the task in the left is completed. Means task in left is the predecessor for each of the tasks in the right. Okay, remember this. Accordingly, you will be doing this. So along with this, each task time duration is also given in terms of days. And you have been asked to construct a network and find the critical path and time to complete the project. This is what we are going to find using critical path method. Okay. So first, let us draw the exact tabular column with task and its predecessors, so that it will be easy for us to frame the network. Okay. So what are all the tasks given in the question? A to I. So task, immediate predecessors and duration. These are given in the question itself. Task starts with A to I. So A, B, C, D, E, F, G, H, I. These are all the tasks given. Predecessors, we have to get from the relation given. What is the relation given? I'll just write it here so that we can compare and do. A less than D, E, B, D less than F, C less than G, E less than H, F, G less than I. Okay, so this is what the task given. So A is the predecessor of D, B predecessor of B, D predecessor of F, C is the predecessor of G. Means A, B, C is not in the right hand side. What does it mean? A, B, C has no predecessors. So A, B, C are nothing but the initial activity. Because the activities in the right of this inequality are the succeeding activity. Okay. So A, B, C are not in the succeeding activities, that is in the right, means we need not wait for any activity to be completed to start ABC. So ABC are nothing but the initial activities. Then what does this inequality means? After completion of A, you have D and E starts. So D starts after completion of A. E also starts after completion of A. So what is this inequality states? B and D are predecessors of F. So F starts after completion of BD. So after completion of BD, F starts. Okay. What this inequality states? C is the predecessor of G. So after completion of C, G starts. This states E is the predecessor of H. So H starts after completion of E. So FG are predecessors of I. So I starts after completion of FG together. Durations are given as 23, 8, 20, 16, 24, 18, 19, 4 and 10. These are all the given durations. First, let us, using the first two columns, let us draw the network. Then we'll construct the critical path. Okay. So first, let us draw the network. So for that, what are all the information given? A, B, and C are the initial activities. So every activity starts and ends with the node. So A, B, C are the A, B, C are the initial activities. Then D, whose predecessor is A. That is, after completion of A, you have to write D. After completion of A, you have to write D. But one more thing you should see is whether D is alone or together in the predecessor column. Yes, D is along with B. So B, D are together means after completion of A, your D starts, but D and B are together. Okay, so you should merge D and B at a single node. Next, after completion of A, E starts. So see in the predecessor column, E is there alone or along with some other activity. E is alone, so you can write it. After completion of A, E starts. After completion of BD together, F starts. F is alone or together with something else in the predecessor column. F and G are together. So after BD, F starts, but G is after C. So F and G are together. Okay, after C, G. After BD is your F, but F and G are together. After E is your H. So H is ending node, so which will not be in the predecessor column. So H is after E. Next, I is after FG. I is the ending node, so there should be only one ending node. So join this I with H. Okay, clear? So after drawing this, give name for the nodes 1, 2, 3, 4, 5, 6, 7. Then I'm going to write the duration of each of the activity. A duration is 23, B duration is 8, C duration is 20, D duration is 16, E duration is 24, F duration is 18, G duration is 19, H duration is 4, I duration is 10. Okay. Then we have to find the forward pass as well as the backward pass. That is earliest starting time and latest completion time for each of the activities. Let us find it one by one. Earliest starting time and latest completion time of each of the activity. At each node, you will be calculating these two. Okay, nodes at node 1, 2, 3, 4, 5, 6, 7. At each nodes, you will be calculating all these two. Okay, at node 1, always you will start with 0, 0. So both earliest starting and latest completion will be 0. Next at node 2, only one activity is entering. So which is 0, earliest starting, first we will calculate 0 plus duration, that is 23. 23. Here at node 3, there are two activities getting in. If there are more than one activity, we will go for maximum. Maximum of what? 23 plus 16, comma, 8, 0 plus 8. What is maximum? 23 plus 16. That is 39. So here you will be writing 39. At node 4, how many activities are getting in? Only one. So which is 0 plus duration 20. So earliest starting is 20. Node 5, there are two activities getting in. So you have to find maximum of There 39 plus 18 and 20 plus 19. Which one is maximum? 39 plus 18, 20 plus 19. 39, 40, 57. So the maximum value is 57. So I'll write the maximum one in the earlier static. Sixth node, only one activity is getting in. So duration plus the previous earlier static. So 23 plus 24. That is 47. Okay. So next, last node 7, there are two activities getting in. So we have to go for maximum of what? 47 plus 4 and 57 plus 10. Which one is maximum? 67. Okay. Next, latest completion, that is backward pass. You should go from the last node. So last node value is same, which you have gotten earlier starting last node. So 67. Start with 67. Next, go to the previous node 6. So how many activities are going out? Only one. So 67 minus duration. So that is 63. Next node is 5. How many activities are going out? Only one. So 67, the value in the triangle, minus the duration 10. That is 57. Next, node number 4. How many activities are going out of 4? Only one. So 57 minus duration, that is 19. 57 minus 19 is 38. Okay, next node number 3. How many activities are going out? Only one. So duration is 57 minus 18. 57 minus 18. The value is 39. Next, node number 2. How many activities are going out? 2. So more than 1 means you have to find the minimum. Okay, minimum of 63 minus 24, comma 39 minus 60. What is minimum? 39 minus 60. What is 39 minus 60? 23. Next, node number 1. So you should get it 0. Let us check it. Because there are 3 activities going out, you have to go find for 3. So minimum of 23 minus 23, comma 39 minus 8, comma 38 minus 20. What is minimum? You have 0 here. So 0 is the minimum. You have got it. Okay. So this is how you should find earlier starting and latest completion time. After that, we have to finalize with the critical path. How to get the critical path? Start with the initial node and see what are all the possible activities, A, B or C. See whether the square values, that is earlier starting time and latest completion times, are equal in both nodes. Okay. So that way you have to travel. 0, 0, 23, 23. So here earlier starting time and latest completion times are equal here. Here in node 3, 39, 39. Here also earlier starting time and latest completion time are equal. Here you don't have equal earlier starting and latest completion. So you need not bother about this. Where you have equal square and triangle, in that case you have to check for whether you subtract duration, you are getting the previous node earlier starting time. So 23 minus 23, 0. 23 minus 23, 0. Yes, for this you are getting. But here 39 minus 8 is not 0. Same way, latest completion. 39 minus 8 is not 0. So you cannot take this path. So I am selecting this path. So to select the critical path, actually we have to see two conditions. One is earlier starting and latest completion should be same. That is value in square and triangle should be same. And then this, if you subtract square value with the duration, previous node square value you should get. Similarly, triangle value minus duration, you should get previous triangle value. Clear? So from 2, you can choose either 6 or 3. In 6, we have 47, 63 not equal. In 3, you have 39, 39. So if you have only one path with equal square and triangle, that is earliest start and latest completion, then you need not check the next condition. We can choose that path. From 3, you have only one choice, that is 5, where you have both are same, 57, 57. So without thinking, I'm just choosing that path. From 5, I have only one way to go to 7, but there I have both earlier starting and latest completions are same as 67. So 5 to 7. So now what is the critical path? Critical path is 1 to 2, 2 to 3, 3 to 5, 5 to 7. That is, in terms of activity, it is A to D, D to F, F to I. Okay, let us find the duration, total duration to complete the activity. So how will you find the duration? In that critical path, the activity duration in each path you have to add, which will give you total duration to complete the project. So 1 to 2, what is the duration? 23. 2 to 3, 16. 3 to 5, 18. 5 to 7, it is 10. Adding everything, 30, 50, 58, 64, 67. So duration is given in terms of days. So it will take 67 days to complete the project. Got it? This is critical path method. Thank you.